Thank you. Thank you for inviting me, and it's an honor to be in National Science Academy, and thank you for considering Australia is doing some research on this topic. It's good to be out of smoke for a while, and I can't talk about microplastic in Australia at the moment. They'll kill me. I can talk about PAHs there. Yep. So we listen a lot more about microplastics and the basics. And what I'm giving you, by the way, this is the first time I'm trying sleep talking. This is 2 o'clock midnight in Australia. And trust me, my slides are not boring. It's a storytelling. I designed for sleep. So I just want to give you a research update down under what's happening in the last 6 years. When we started microplastic research in 2014, and we started talking about, because I'm from soil background, contaminated soil background, we start asking questions about weathering effect and what will be the implications of weathered microplastics. And that time I tried to contact with collaborators. It was hard to find anybody working on weathered microplastic. And in fact, it was a surprise when people, what is weathering that time? So it was a good start that time. And then we started with, am I pressing right? That's the big one. Sorry. Good. Yeah. We started with understanding the letter P. If anybody synthesizing chemical or material, don't name it with P. Pesticide, PAHs, PFAS, everything gets into trouble, okay? Just change the name. And my students think that's the only reason plastic is an issue. And also, when plastic was invented in 1941, it was coincidentally said, a world filled with objects made from plastics. That was in this book, 1941. Unfortunately, with all due respect, we feel this now. And also another coincidence, National Academy of Science, 27th workshop on 27th January. It's something coincidence. So it rightfully reflects the way we are in and the world we are in, human health and environmental aspect-wise. And also the exposure-wise, the data is increasing. So flooding of papers you would have seen in all journals, except we don't have journals called microplastic. It may come soon, but it's a lot of paper. And also the exposure levels also keep on increasing. You can see the per capita emissions are in grams, and even for microplastics. This is a model data, by the way. But the understanding of the adverse effect is still lacking, as mentioned by previous speakers. And data gaps, uncertainties, and also ignorance are affecting our understanding of the risk. And this was similar to Zara's talk. We tried to do mass calculation using the reported data, and we arrived these figures based on the available data. So if we see a scenario 2, scenario 1 is 0 grams of plastic ingested. Scenario 2 is 0.1 gram per week we may be ingesting based on the available data. And the sources are drinking water, salt, shellfish, and beer. And yeah, I don't drink beer. And these are all published papers. So, and we try to derive a mass calculation because we wanted that number to feed into our human health model studies. And when we assembled all these publications, we looked at around 100 papers which were reporting about dietary presence of microplastic. Around 50% of them actually fitting into the data requirement. And also, as Bart mentioned, the data quality is not sufficient enough to confidently say we are ingesting this much. Mainly, we are lacking the size-wise data and density and shape as well. And also, we emphasize the further need. So we'll build the database in such a way, as and when the new data arrives, we'll be able to feed into the existing database and we can refine the value. And also, if you see the size distribution reported in the paper, depending on what sampling techniques and which column they are sampling it. If they use 10 micron filter, you will see the spike in number. If you are using regular plankton net, you see smaller size of microplastics. And after we estimated that, within few months, we realized, we might have underestimated it because there's so many more data is coming like tea bags and seaweed-based microplastics. So still, it's going to flow in, and a lot of stealth microplastics still not yet analyzed, and this data may refine very quickly. And so from this mass calculation, I want to take your attention into our understanding on the microplastics in water cycle. So when we talk about human health, ingestion is the main focus. And even if you don't ingest, that is still going into the water cycle. And then again coming back to you. That's one factor we should remember. By not ingesting, you are only temporarily avoiding that ingestion. It's going to go back to the water cycle, subjected to progressive fragmentation, and again come back to you. In urban environment, this is a typical water cycle, as we all know. And in a lucky developed countries, we have a structured wastewater plant. So most of the microplastic introduced in the wastewater is actually getting into the wastewater. But in developing countries, there are wastewaters in non-point sources. So it directly gets into the fresh water and also other aquatic bodies. So this is a critical thing which is missing right now in the literature. And if I can reflect on how wastewater process works and how much is removed, we all know the primary screens. The primary screens can filter up to 1.5 millimeter, which is no way related to close to microplastic we detect in the toxicological endpoints. And also, current wastewater treatment facilities claim they can remove 60 to 80% in the primary treatment and 95% in the secondary treatment. Removal doesn't mean complete removal. Removal is just compartment transformation. And the remaining goes to the effluent. And so removal actually added into the biosolid. So when you look at the different types of wastewater plants, most advanced one, if you see tertiary wastewater plant, we are still releasing in the treated water after all those removal, millions of particles a day. This is a typical Australian wastewater plant, 400 megaliters a day. And if you calculate based on the particles we detect, it's around 80 million particles a day. So this is directly from us. And if you think, is that all? No, that's all we've had so far reported. And the improved methodology is still required to capture everything, and mainly to detect the fine microplastics. You will be surprised some of the microplastic we didn't discuss today. I'll show you in the next slide. And those removed microplastics from the wastewater, it goes to the biosolid. As we all know, biosolid is a major nutrient source and next phosphorus source for the world. And that nutritive value is affected because of the loads of microplastic. If we see from our reported studies, there is a huge variability in terms of microplastic in the biosolid, ranging from 0.2 grams dry weight basis to 500 grams in the sludge. And also 370 in the wet weight and 240,000 numbers in dry weight basis. A huge variation. Again, there's a methodological challenge here, because unlike marine water and fresh water, wastewater and sludge is so complex to work. And whatever the technologies or sampling techniques we have, it's not easily adaptable in the wastewater. And still we don't know the impact of biosolid derived microplastics on the contaminant transport and soil microbial assemblages and the biota. There was a question about how plants takes up. There is no studies regarding that. And if you look at the biosolid application, explain you more. And this is from our study using our improved methodology. This we got accepted in water research. It may be available online in a couple of weeks. So we found, as usual, routine polymers, fibers, and fragments, and this fellow. This is not reported in many papers. This is a glitter, which we may not know it's a plastic, but it's a plastic. It's the most notorious plastic, and I'll tell you how much we got. And also this fellow, fruit sticker. We thought it's paper, but it's a fruit sticker. It is bigger size, but once get into the wastewater, it rolls into small, easily digestible pellet for anybody. Unless you open and see it in a microscope, you wouldn't recognize it's fruit sticker. The sticker you see, it's actually recovered and washed from the wastewater. And in our study, the sludge loading, based on our improved methodology, sludge loading, microplastic loading is around 11 to 12 million particles a day. And also effluent, it's almost 0.1 billion particles a day. It's based on improved metallurgy. And as I mentioned, glitters were abundant in the sludge and also in the effluent. That's 2.41% when you compare to the million one. It's still a lot. And glitters, unlike other microplastic, it is coated with aluminum. It's coated, so metal-coated polymer. It's more challenging, and it's difficult to get rid of it. So the only way, when you use glitter, only way to get rid of is washing into the wastewater. So when we report to our wastewater utility also, they were surprised they're getting this much. And this is not the same for all the wastewater though. And the particular wastewater we investigate is in the middle of the city. So lots of activities involving glitters. And also the glitter composition also not publicly known. And not many people heard glitter toothpaste. You can Google. It's a famous brand, glitter toothpaste. And that is still a polymer one, although beads are banned. And this metal-coated particle, it behaves differently. When you are analyzing, when you are sampling wastewater for microplastic, you can easily miss it if you are using density separation. And here, we really need the expertise of the operator and also replication and quality assurance. And in this particular study, I'll explain to you. The quality assurance for wastewater is totally different. How we follow is we spike the wastewater with the known number of microplastics of particular size. If you are able to detect 20 micron, we spike close to 20 micron size, and we make sure recovery is close to reproducible recovery. Not only that, we don't stop from there because it's also operator skill. So we give the same recovery studies to 3 different lab members, and then we'll see is there operator-based bias. That's critical because we have noticed, a less experienced person can easily overestimate or underestimate the concentration. And the second study is interesting. This wastewater, most of the developed countries, we release it through ocean outfall. The ocean outfalls for nothing but all the treated or partially treated wastewater gets in there. And you can see these microplastics are recovered from the ocean outfall, which is 1.5 kilometers away from the wastewater. Still, the biofilms are coated. This is in the vicinity of wastewater plant. And what we don't understand in the microplastic is the power of biofilms. So biofilms have the potential to change the fate of microplastics in the environment. And it doesn't matter what environment, mainly in the water, it's actually a bit rapid, but biofilms have the potential to change the density and change the chemical composition, change the interaction with the relevant compartments. And the third study update is understanding the implications of microplastic in the blue economy. And we do agree what you see in the fish gut is actually removed when you gut it, which is safe. But we also, based on these studies, see in Australian supermarkets, when we sample, we find around 5 microplastic per organism. So it's in the gut. So we can say it's less risk. But when we did the same thing in India, we found up to 20 microplastics in the GI tracts. But the trick here is, not many people know, again, the difference between the fresh versus dry fish. In developing countries, they don't have luxury of fridges and refrigerator. So dry fish is not gutted. So still ingested directly. And if you look at the developing countries like Bangladesh, underdeveloped like Bangladesh or India, up to 40% consumption is dry fish. So still, whether gutting or not gutting, still it's going to human gut. And what about the filter feeders? We did some compilation on geographic patterns of microplastic ingested by edible marine bivalves. And you can see the geographic pattern, it changes a lot. And the particle-wise, the consumption changes from 11,000, close to 12,000 to 53 in Germany, where relatively clean environment. And this is another interesting bit because these studies, not all of them reported about the clearance mechanism of bivalves. And when we looked at the clearance mechanism, not all of them actually able to be cleared like other chemicals. We saw average 4 particles still retain after 72 hours of clearance. And so by considering all these study updates, should we be concerned about the human health? Yes, unlike other contaminants, but the smaller size, we call fine size, or you can call them nano size particles, are the direct effect as of now. But large size particles, as mentioned before, it may not be directly entering the human body as such, but it is still in the water cycle. We are going to continuously expose to it until we remove it. And also, we need to understand the clearance mechanism. This is where we need to investigate more on the size, whether size matter here. What size, we clearly need to know what size is actually absorbed, what size is actually, potentially breakdown or, changes, transformation within the gut environment. And also, we need to understand the size-based implications of plastic-associated chemicals. These are all nothing new. This is already last 20 years. There's a lot of papers about bisphenol A or cadmium flame retards in the plastics and packaging. But how we are going to relate it to the size-dependent toxicity? Because we still, although we are ingesting, but still the chemicals are associated in. So we need to relate that particle-related toxicity to chemical-related implications. And also, this is again the same size-based. We need to understand the size-based implications of the microplastic related to the hazardous plastic monomers. And also, based on our research and ongoing activities, we try to apply the total environmental exposure, considering microplastic as a three-dimensional contaminant toxicologically. So it's a contaminant as a particle, and also chemical, and also the biofilm pathogen-related things. So we try to apply the overall total exposure concept in this. And finally, I would like to introduce and thank my hardworking team. And without assembling such a strong multidisciplinary team, we wouldn't have achieved this much. And what I presented to you is a nanoplastic level of what we are doing right now. And we are focusing from 2020 is microplastic issues in developing and underdeveloping countries, because that's where lack of knowledge, lack of awareness, and that's where we need more science, because it's hard to control in the developing and developed countries. So we formed a global environmental plastic research alliance last month. So we brought together various researchers from developing and underdeveloped countries, and we're trying to capacity build and help them. And this is the brief research, ongoing research activities within my team. And we also started how we can tackle the future plastic, which is bioplastics. So what are the benchmarks we can set up? And also what are the guidelines we can support in terms of sustainable bioplastics for complex application, not for the cutleries, it's for complex applications. And these are all my ongoing thesis and completed thesis from my team. Thank you so much for your attention.
Wow, great. Thank you so much. We actually have enough time, I think, for just one or two questions. Sure.
I have a question. That was a terrific presentation. In your animal studies, other than the GI tract, are these particles depoting in other normal organs, such as the liver or spleen? Is there any data on what organs they're depoting in?
I haven't seen any data on that directly related to microplastics, but I think there are other, like soil, contaminated soil, there are some studies, but it's totally different compartment. So it's hard to compare contaminated soil to microplastic. But as I mentioned, I was talking to many people, and human health-wise, we haven't reached that stage to either disregard microplastic is not toxic, to either declare microplastic is toxic. But as a common citizen, it is not a natural material. So I treat it as a contaminant and treat it in a conservative way.
Yeah. Again, based on our research with drug-delivered nanoparticles, the liver, spleen, and lung is where these things depot in. So if they're absorbed, that would be certainly an organ or a compartment to look for them. Thanks.